Keeping track with the series on relations and functions. In a minute, we're going to work on mapping diagrams, identifying the domain and range of a function. But we'll talk about that in a second. What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, we're going to be talking about the domain and the range of a relation, identifying those two, and then determining if that relation is in fact a function. We're also going to talk about a mapping diagram. It's a old school concept, but it helps you identify the domain and range, and it also is another way of helping to identify if a relation is a function. So let's go ahead and get into the first example. So I want to do three things. I want to identify the domain and the range of the relation that you see behind me. I want to show it in a mapping diagram, and then I want to determine if that relation is indeed a function. So let's go to the first example. So we have the ordered pairs -2, 0.5. We have 0, 2.5, 4, 6.5, and 5, 2.5. So in order to determine the domain and the range, remember the domain is the x values and the range is the y values. So we don't have to put them in any particular order, but I'm going to say -2, 0, 4, and 5. And then I like to have them in numerical order, but whatever. 0.5, 2.5, and 6.5. Now, notice I didn't write this 2.5 twice. We don't have to list the numbers twice, even if they are listed twice as an x coordinate or a y coordinate when we're doing a mapping diagram. So, a mapping diagram, I'm going to map each x value with its corresponding y value. So remember, x is the domain, y is the range. So in the ordered pair -2, 0.5, I'm simply going to draw a line from -2 to 0.5. You can draw an arrow or a line, it doesn't matter. Then we have 0, 2.5. Boom. We have 4, 6.5. And then we have 5, 2.5 as well. Now, notice that 2.5 in the range has 2 arrows going to it. So if we want to determine if this is a function, remember a function is when a relation has every domain value has exactly one range value, right? Now, we have 4 different domain values, and each of them have exactly one range value. If you notice, there's only one arrow going from each value in the domain to a value in the range. So this is indeed a function. In this second example, we're going to do the same thing. The only difference is we have a different set of ordered pairs. All right. Now, so in order to draw the mapping diagram, I'm going to take the x coordinates again. So I have 6, 4, 6, and 5. So let's do 4, 5, and 6. I just like to put them in numerical order. And then I have 5, 3, 4, and 8. So 3, 4, 5, and 8, right? So now, for the domain, 4 is mapped to 3. So boom. 5 is mapped to 8. Sorry about my squeaky markers. 6 is mapped to 4. And 6 is also mapped to 5. So if you ever want to check to see, to make sure you have everything mapped together, I have 4 ordered pairs, so I should have a total of 4 lines in my mapping diagram. 1, 2, 3, 4. But notice this 6 has 2 lines going from it to a value in the range. So remember, a function, it has, a function is where a relation has every value in the domain is mapped to exactly one value in the range. So since this 6 is mapped to more than one value, then this is not going to be a function, all right? This is not a function because 6 is mapped to 4 and it's mapped to 5. Same thing in this example. Just a new set of ordered pairs, new relation actually. And let's decide what our x values are. The smallest one is 4.2. Then I have 5. Then I have 7. Notice we did not write 4.2 twice. When we're doing a mapping diagram, we only have to write each number once. And so then our values for our range are 0, 1.5, 2.2, and 4.8. And now we just have to map them together. So when I map them together, let's see, 4.2 is mapped to 1.5. It's also mapped to 0. That should stick out to you already. 5 is mapped to 2.2. 7 is mapped to 4.8. So notice that 4.2, it has 2 values that it's mapped to in the range. So this is not a function, okay? It's not a function. So we have another relation here, negative 1, 1, negative 2, 2, 4, negative 4, 7, negative 7. In order to get the mapping diagram, let's see, we'll go from negative 1, actually let's do negative 2 first, because it's the smallest number. So let's go negative 2, negative 1, 4, and 7. And then I have negative 7, negative 4, 1, and 2. And I want to map those together. And when I map those together, let's see, negative 2 goes to 2. So, boom. Negative 1 goes to 1. Squeaky markers. 4 goes to negative 4. And 7 goes to negative 7. Boom. All right. Now, 4 different lines. So we got all 4 ordered pairs. Now, each domain value is mapped to exactly one value of the range. So something to remember when you're doing mapping diagrams, if you want to identify whether or not it's a function, you can have only one line coming from each domain value, all right? You can have multiple lines going to the range values, but you can only have one line going from the domain value. Share this with a friend. Thank you for watching. Like, share, and subscribe. And once again, Young Gurus Math Tutoring, I've got the solution to your math problem.